Welcome back to another new AMP podcast. I'm Ben DuVos, news editor with the AMP publications team. AMP, of course, is a shorthand acronym for the Association for Materials Protection and Performance, and both Materials Performance, or MP, and Coatings for Magazine are member magazines within our publications group here at AMP. This episode is part of a special series spotlighting the winners of the 2025 Materials Performance Corrosion Innovation of the Year Awards. This biannual program is designed to celebrate cutting-edge technologies that are driving progress in corrosion control and protective materials. Even though it's technically 2026, we are still in the 2025 cycle as it pertains to the program, since the latest awards were handed out last spring. The next edition of the program will be for 2027, with nomination guidelines set to be announced, I believe, in April or May, or June at the absolute latest. So today we're featuring one of the standout from our latest class of winners, and that's the portable plating shop for on-aircraft coating repair from Cordesa. Based near Atlanta, Georgia, Cordesa has a line of robust, non-drip ground support equipment that packages a complete plating shop into a single portable unit, which is designed to repair and replace damaged or missing coatings. Joining us to talk more about that is Dr. Alan Rose, CEO of Cordesa, and Dr. Siva Palani, Chief Technology Officer. In this episode, we're going to be talking with them about the science behind their innovation, what this award means for the company, and then ultimately how the technology is already making a difference out in the field. First off, thank you both for taking the time to join me today. Why don't you each start by telling us a bit about your career, as well as something about Cordesa as a company and how your role fits in. Alan, as CEO, we can start with you.
Okay, thanks, Ben. Good morning. Yeah, I'll give you a little bit about my background, and I can tell you a bit about Cordesa, and then hand over to Siva, and he can explain his role. So my background, I did my bachelor's in aero engineering, PhD in chemical and process in England, and I got involved in simulation very early on. So that was almost 4 decades ago. So I've always been involved in computational fluid dynamics and using simulation to speed up product design. And I worked in the nuclear industry, gas turbine industry, got an interest in hazardous materials, safety, fire combustion. And then almost 2 decades ago, I started working into electrochemical simulation. So that was like plating and corrosion. And I got together with another expat here in the States, Keith Legg, and we created Cordesa in 2011 with a focus on applying electrochemical simulation for looking at these processes for repair of coatings, creation of coatings, deploying coatings to the field more quickly. And now we have Cordesa's kind of requirements to retirement. We get involved in the sustainment and the repair, and we also get involved in prediction software up front to the left. Obviously, we're going to talk about repair today. So I'll hand over to Siva.
Yeah, so my background is I'm an electrochemist. When electrochemist means that it's on the corrosion investigation and also the corrosion protection. And my career spans distinct phases from innovation from strategic management across automotive and aerospace sector. I began my career at Nissan about 15 years ago, and then I got into and then I joined Airbus and advancing more my doctoral research as a project manager, focusing on material science and electrochemistry, and of course trying to push computational modeling when it comes to corrosion prediction technology.
So let's talk about the winning innovation. And for each of these questions about the technology and the innovation itself, you both can speak to it if you want, or if you want just one of you to respond, that's fine as well. Whatever you think is appropriate for each of your areas of expertise. As far as general background on the portable plating shop, what were the origins? Just walk us through how it started out and what the market shortcoming or trend is that it hopes to address.
Okay, I can tell you a little bit about the need and the background, and then maybe see if I can touch upon some of the technical aspects if I missed them out, or the area that he's closer to. So essentially, there was a big problem. We started off doing a lot of SBIR, small business innovation research. There was a need for predicting, addressing, repairing corrosion on aircraft, because obviously when the aircraft are in the depot being fixed, they're not mission capable. And it was quite alarming across the DoD fleet. There were numbers of mission capable of 50, possibly even as low as 20%. So corrosion had a big play in this, making aircraft unavailable. Also, the cost was extortionate. And it's not just having a repair method. With this repair method, if you can repair all the actual assets on the plane, you can do it at the line or push that repair forward. But in order to do that, it has to be a process that can easily be used and applied, wheeled up to the aircraft, used, and wheeled away. So it's like bringing the electrochemical aspects of the plating plant, anodizing, or whatever, to the plane. Because if the plane is based somewhere away from the depots, then you have to disassemble a part of the plane and then package it and ship it, and then it has to go to a plating plant, and it takes weeks rather than 10 minutes to an hour. So that's the kind of need, but it had to be clean and it had to be safe. And there was a technology was aware of, kind of a non-drip technology that had been used in smaller tools, and we saw the gap to kind of package this in a robust mobile package car with our rectifier and pumps and tools. It started off with the F-35 program. We can dive into that a little bit. And then we expanded upon those capabilities. So that was a need, really, to try and bring the repair forward, make it very fast, keep the planes flying.
So that's the background. That's where this all started. Let's talk about the development process. As you were bringing this to market, what were some of the questions that needed answering? What were some of the tests that it needed to prove? Just take us through what the steps were that needed to be in the development process in order to get this to the commercialization phase.
Yeah, well, that was quite a learning process for us, because there's a big gap, and people call it the chasm, or you can have a prototype or a good technology. So we had a non-drip process. Okay, so there's this tool that gets supplied with electrolyte, soaks up a pad, and then there's a vacuum applied to it, so the tool doesn't drip. And the balance and the trick is too much electrolyte, it'll drip, too much vacuum, and it'll be dry and it won't work. And we wanted to make that work on larger tools, and that was really tricky. So we introduced computational fluid dynamics, which is from my background and some of the guys that work here. And we developed a model that allowed us to predict whether certain design and size of tools would drip or not. And that speeded up our development process incredibly. So, you can have that best process and, a really good process. It could be the best one in the world. But if you can't commercialize it, then, it's a white elephant. So to commercialize it, you move from your process. We proved it was non-dripping, so that was great. But now if you're applying it to, high-strength steels on aircraft, you've also got to prove that it's non-hydrogen embrittling. So, I can hand over to see if I can give some details, but there's tests there, STM F519 notch specimen tests, where we had to coat them with, first with cadmium, which is a legacy process. But at the same time, this was for Lockheed initially, the plating piece, and they had an initiative to reduce the amount of cadmium, hazardous materials, and chromates in all of their processes of manufacturing of the F-35. So in line with that, we also had to qualify a zinc nickel replacement for the cadmium as a brush plating. So there was a bunch of tests there, and they had to test for corrosion and how durable that repair was. Can you use zinc nickel as a repair over the cadmium? And then when we were packaging this, you got to think about it. This was all over the world. We've now sold 108 of these. They're wherever the F-35 is, this is where you have these systems. It's part of the standard ground support equipment. And we deploy people to go train those folks all over the world as well. And it can also operate in aircraft carriers. So there was things like it has to non-tipping, it has to be on a 15-degree angle without tipping, has to be very robust. There's non-skid on aircraft carriers. That's very rough if you've ever seen it. So, you push this along, the wheels have to be absorbing. You have to have shock absorbers because you've got the electrical equipment. It's essentially a rectifier in the apply the DC voltage for the process. Also operates near aircraft that may be fueled or certainly fuel volatiles around. So there's ATEX considerations. So we had to look closely at the tool design. Essentially, you're making a circuit, you connect the negative to a part of the airplane, and then you have the tool, and then where you're repairing on the airplane is, essentially the workpiece. So when you touch that with a tool, you're creating an electric circuit. So obviously, you don't want to be creating sparks. So there was things that we had to do to avoid the creation of sparks. So that had to be tested. Also, it works in depots. It's working near airplanes. So you have to think of every little nut, bolt, and piece in your system for FOD, flying object debris. So that's kind of a logical exercise, just kind of diving through the design, make sure there's no pieces that can fall off and create a hazard. Also, it operates in very harsh environments. It'll be fixing corrosion. So you don't want the ground support equipment itself to corrode. So the finish on our own system and the car is quite robust, not containing cavial chromates. So, like the electronics as well have to be protected internally. So there was all these pieces that were brought in to make this work in a commercial and a hazardous environment. And that, to be honest, we kind of underestimated the effort there, but it was a great experience to move it from prototype to what people will refer to as the first article. Okay, let's take a look at it. We can kick the tires and use it, and the customer would test it, and then eventually to full production. So we're a company of only just 13. That was quite a big program for us. That's kind of a broad overview of the tests and requirements that we have to look at when using ground support equipment. Siva, is there any things that you want to touch on, or Ben, if you wanted to ask me anything more on that aspect?
No, I think you covered pretty much everything that I wanted to say. But yeah, when it comes to, I know we call it as a plating shop, but it's more, we will call it as an electrochemical treatment shop other than that, because we do more than plating as part of the, so we are, constantly engaged with civil programs with C5, so, and we're doing not only plating, but also corrosion removal, and then also treatment when it comes to passivating, and also as sealing for anodizing processes. So my point being is that it's more to it as beyond plating.
Yeah, that's a good point. I guess that's where the future is. We've enhanced the processes. Like Sigurd said, we got like the corrosion removal now. So there's quite a large cart with 5 or so tools on it. It will do corrosion removal. It will do anodize of any damaged aluminum around the fastener. It will plate the fastener. And like Siva said, passivate and seal, all with chromate-free electrolytes. So, that's definitely where it's going, is expanding that capability, more processes. And because there's more processes, we've also introduced a computer control as well to step the technicians quickly through each of those processes, ensuring they're using the right tool at the right time.
All right, let's talk about where we're at today with this technology. When did you get to the finish line, if you will, in terms of moving this to market? What's unique about it today in the marketplace, and what are the types of, projects or assets that it's used on?
So our big success, I mentioned it before, is the F-35 program. So that started earlier on and got us on this road, which is why I keep referring to plating. So there's 108 of those systems out there now. We've provided training throughout the US, Japan, and Australia. So, that's a very successful program. And as the F-35 program grows, so does that as a standard ground support equipment. Over the last few years as well, and we kind of touched on it in our innovation award, we kind of widened that capability, like Siva said. So, for instance, we got an award to look at the C-5 program. That's the big cargo transport U.S. Air Force aircraft. It's huge. In fact, the length of the C-5, you can play tennis in there. It's huge, and it's actually longer than the original flight by the Wright brothers. So it kind of puts it in context. And in there, they can have helicopters for transport and tanks and so on. And the floor gets damaged. And that anodized floor, the C-5, like B-52 and these older planes were over-designed, very tough. But when they put a patch to fix that, to repair the damage on the floor, they remove some of that old anodized. So they were very interested in using our technology to wheel in there and repair these patches and bring that back to kind of factory condition, as it were. So that was one thing. We did a demo on that a couple of years ago, and that's being adopted by the C-5 program. A challenge to that was now, instead of the 1-inch kind of size tool that we use on landing gear and small dings and scratches, this was a much larger area. And we put a lot of development into larger tools for non-drip. So that took quite a while. And a C-5, you can have like 300 of these patches. It's huge. Then the PA program, that's a Sub Hunter, which is actually a Boeing 737, but in the military version. They had a corrosion issue on the raked wingtip leading edge. So now we're talking much larger areas. And to disassemble that piece, it's possible. And it can take a while, but it's possible with our technology to actually fix in place. And that was another kind of that was an anodizing repair. And then we moved into the U-2 program, which is a very old program, Dragon Lady, it was a spy plane. And that was suffering a lot of corrosion issues. And they wanted a total solution from start to finish. So with Siva and his team, we developed the processes for electrolytic corrosion removal. As I mentioned, we can remove that corrosion. We can strip any remaining cadmium out, the anodize and plate. So we have all these processes stacked up in a much larger package. So now we have interest in other fighter programs, and we've got some commercial interest. And another interesting piece is we've had electronics firms and other firms get in touch with us because they have hard anodize on some of their equipment, and it can be very expensive to disassemble that, and we can fix it in place. So we're actually moving, seeing applications in adjacent industries as well. And brush plating traditionally has been kind of a messy type of process. This makes it clean, so much so we have customers now, prospects that are looking at the use of this process actually in the manufacturing line. You can actually slot it in there because there's a program where there's pieces that are anodized, and sometimes when they fit them, they get dinged and scratched. And if they have to send them back, it holds up the production line, and it takes like 3 weeks to get replacement parts. And with our technology, we can fix that, and it will just take a few minutes. And to put a scale on it, about 50 square inches will take about 12 minutes to anodize. And if it falls in those parameters, then we can bring some real value. Siva, I'm thinking about most of the programs there. Is there any additions there?
No. I think you hit the nail. The point being is that it's awareness. Okay, when it comes to electroplating and brush plate, and what we have learned over the years is that it's a challenge and trying to get people to buy into this technology, right? And the fact that is that they don't believe, right? And so people don't believe that it's doable, So way back when we got some people from the DoD come over to our facility and testing, non-drip anodizing, okay, from the leading OEM counterpart that they were there as well. And then they saw that, and then they said, "Oh wow, it works, and that's the thing. It's not about whether it works or not. It's just about trying to get people to understand and give them the enough information so that they can go and deal with it. So that's kind of a challenge for us, in terms of how we can drive this technology. And so other than that, with simple programs that we have so far and been very useful, and then people have seen and they've been more acceptive of the technology moving forward. But I think we can do better how we can sell the technology. And yeah.
So the SIBA's reminded me of something. It's strange. We come with this technology where you can actually on an asset do an anodize and repair. You don't have to send it off to the plating anodizing shop. And like SIBA said, folks didn't even know this existed. But they may have heard of obviously brush plating, but anodizing and then non-drip in such a clean way. So it's been strange. We've done a demo, a demo we call it, and it's like, great, it works. And we tested it on an actual plane, on an asset. And then it kind of came to a halt because there was no specifications in place that could accommodate anodizing repair on a plane because the technology wasn't there. So that's something I've also learned as well. We've had to engage with our customers to help them test, validate, and get the tech data that they need so that they can get their local and national specs up to spec, as it were. So, you have this great technology, but if there's no spec that kind of enables and accommodates it, then you're stuck again. So we're actually, and that's one thing I like about working with the military. Many of the military will own their own specs, and you can work and collaborate with them to accommodate these new technologies. So I thought, that was interesting that you mentioned that, SIBA, whether they believe it or not, and then when they see it, their hands are still tied because there's no tech orders in place that can accommodate it unless you've mapped that out and identified it already. Does that make sense, Ben?
Yeah, I think so. I was going to ask the feedback that you've heard from users and asset owners. You touched on this a little bit already, but just generally speaking, when people have installed this, when people have used this, what are you actually hearing from the field about how this is actually functioning?
So a couple of years ago, we became ISO 9001 certified. So we think very actively about the quality and feedback. And it is tricky getting feedback, certainly on the military side. So I kind of anticipated this question and asked them and looked at our quality surveys. One response was no news, but no news is good news. So that was literally from one of the programs, and they can't tell us where to repair the aircraft or when or how often, but they're managing to do it, and it's doing the job, and they have no problems. And they order the consumables and move on. So that was one aspect. The example I gave you on P8, they keep bringing that same plane in. We first did a test on the pitot. It's like a plate on the side of the plane where they have the pitot static sensor, and that was like 50 square inches anodized repair from lightning strike. It just came up all of a sudden. Our program vectored from looking at a plating, and they asked us, "Oh, can you do anodize?" And that's what kicked it all off. And that's been flying now for 6 years, and they keep looking at this, and it's just like brand new. And also about 3.5 years ago, we did a demonstration validation on that raked wing leading edge of the P8, and that's been flying. And we did a lot of tests on coupons before that, and they just stayed in the corrosion chamber test for a long time. I think they just got tired of reviewing them. So the feedback's very good. The quality and durability, certainly the anodize, is proven. People who are using it, they get a little bit, well, not scared or overawed about the machine when they see it, because as a ground support equipment, it is perhaps more sophisticated than some others. You've got these rectifiers and buttons and tubes and stuff, but with the right training in place, it's a very straightforward process and you step through it. Any other feedback? I think that were the main things first. Yeah, the PA F35.
C5 patch on the table.
Oh yeah, and the Sim 5. Yeah, on the dam valve, they just couldn't believe it. It's as soon as we did the demonstration, one of the MP guys up there with his key started trying to scratch it away, and he was so pleased because several years ago they asked, wouldn't it be really good if we could just anodize this straight after putting the patch on the floor? They just couldn't figure it out, and that's been done. I think that's it. Siva, have you got anything to add to that?
Yeah, if I may, I was at Jacksonville, Security Center, Jacksonville, and where all the P8 aircraft is being, what they do and all that. And yeah, so part of the conference that we have gone through, and what I saw that is that it is a burning issue for them when it comes to corrosion. And I was part of the kind of the program, and then they said, "Oh, well, we have a system that gonna deal with a corrosion when it comes to red wingtip, because the program or all the equipment it deals with 737, right? And they don't have a solution for today. And the problem is, and then we trained them 2 weeks ago, and they are very interested in trying to get things put together. And the end goal is to get a process or system put together so that they can and use the system that we delivered to them 2.5 years ago on doing a non-drip anodizing on red wingtip. And so that they came over and trying to understand the process. And I think they are sold on the idea. And the thing is, if we are trying, we are communicating with them in the process and trying to get so that they are fully sold on the idea of doing not on asset, because the piece will be removed from aircraft, but still, it is much more, safer and cheaper way to do repair, as opposed to, if they will do send the whole thing to a external supplier and stuff, trying to do anodizing, re-anodizing, or even conversion coating, so that's very kind of intriguing, something that we are working on. And I think it is very important that we try to sell this new technology for people, because even though, especially on the MMP people, so not everyone is dialed into this, so it's a challenge. Okay. But yeah, we do what we can.
You made a good point. It's not always on aircraft is great, because the first test we did on the P8, it flew in, we fixed it, it was out on patrol by the afternoon, which was great. But like Siva says, it's not always possible. They will disassemble things, but rather than have to send them out and suffer that supply chain, you can still do more with your own equipment in a depot. So yeah, where we're going with it, we're getting civilian maintenance, repair, overhaul interest as well now.
what does the future look like as far as next steps? Are there any enhancements, expansions, new adaptations? Just what do the next few months and years look like for you guys at Cordesa and specifically with this system?
Okay, so one thing we try so hard, and we've eventually got a larger tool design because people wanted to do more and more and more, and now they're asking for a smaller tool design. So that's one enhancement. Where imagine a tool as big as your thumbnail, and it may be elongated somewhat, so you could get into inside corners. So one thing is a series of bespoke tools for specific jobs, and reacting to customers that clearly want that. We've been providing that, and we're currently testing a small tool to do just that. The other thing as well, on the U2, it's a much smaller platform, so we were able to kind of work the process to remove corrosion and replay, reanodize, and so on, rinse, seal, passivate a fastener at a time. And if you're doing a couple of dozen fasteners that you can't remove because they may cause a kind of maybe a structural issue or fatigue debit, you have to do it in place. But now the interest is on the larger platforms. So we work very hard, and we've created a tool now that can treat a number of fasteners in a line at one time. So that's definitely a significant improvement. So that's a very unique technology, the way that you can plate fasteners and also anodize the surround. If you think about it, there's a lot of technical challenges to that. So we've managed to do that. Also, since some of these tools are requiring the ground support equipment requires so many of these processes, the computer control, we made use of that. This steps the technician one process through the other, they just push the button and just kind of follow the process, and then it switches on and off the various pieces. So that's been very interesting. We've even looked at cobots as well, because it can get quite strenuous and repetitive doing this. It's like coloring in, actually. Remember at school with the pens and crayons, you color in. That's essentially what you do with this tool. You kind of do that for a number of minutes. So people are interested in automating it or semi-automating it with cobots. What others? We've done larger tools, small tools, more processes, and then actually inserting this capability, just why you have CNC machines and milling machines, and then they may send this thing off for, plating and finishing. If it's only a small part, then why not have a kind of a, plating, anodizing unit operation as well in your manufacturing line? And that's something that we kind of looked at, because there are various structures, whether it's nuclear or in space, where they have aluminum alloys, friction stir welding. As soon as you friction stir weld, you destroy that anodize. And, if it's a large structure, you might not be able to afford to put it into a huge anodizing tank if you can find one. Why not just re-anodize or recoat and protect that 2, 3, 4 inch street, weld heat affected zone? So that's an area as well where we've developed, in fact, we published a paper in M&P a few years ago on that, where we developed a coating specific for protecting friction stir welds on spent fuel nuclear, the canisters. I think I've touched on most of the enhancements. See, you ever missed anything out there?
Yeah. What did Jet jump in? So when it comes to new developments, is that we are working on some, at least in the area of making this non-drip treatment system that's more approachable, more mobile and smaller stuff that we're trying to do. I cannot say too much about it, but yes, we are working on the way that that people, the way whatever tools and systems we have today, they're huge and they have their challenges in terms of they do what they can do. But then, as far as what the feedback we got from the DOW, Department of War, is that they want some stuff that's more mobile, and we are working on that. And yeah, so their challenges comes with it, and we are working on that and trying to get some more smaller system and more mobile, so that people can get to wherever they need to treat a problem. And of course, it is not only a hardware system a problem, but also a process, right? So it is something that we are working on. But yeah, so that's something that in progress for us, in terms of what we have today versus and where we are going with it.
Excellent insight. Gentlemen, for any of our listeners that might want to learn more, what are some of the resources that you all have available online as far as website, social media, anything you'd like to plug to help our listeners learn more about this technology and other things that you have going on at Cordesa?
Well, the first thing will be our website, cordesa.com. That's CORRDESA. So on there, you can go to the hardware piece, and we'll have some blogs and press releases on the latest and greatest in what we've been doing here. Some background, so that's definitely a good resource. And then there's a contacts page there. If there's any further questions, folks are just welcome to contact us and ask more questions about the technology. So that's definitely the first resource.
Gentlemen, thank you so much for taking the time.
Okay, thank you very much, Ben. Have a good day. Take care.
Thank you.
Great stuff there from Dr. Alan Rose and Dr. Siva Palani. You can learn more at Cordesa.com, and they're active on LinkedIn as well. Just search for Cordesa. And with that, we'll bring this episode to a close. On behalf of AMP, I'm Ben Dubose, and if you want more resources from AMP or our publications within the association, just visit ampp.org, amp.org, coatingsformag.com, or materialsperformance.com. And to learn more about the MP Corrosion Innovation of the Year Awards program, just go to amp.org/MP Innovation Awards. As always, thanks for listening, and we'll be back soon with another new episode.